All right, it is 7:30, so we'll go ahead and get started. Again, what we'll cover is kind of the material from this week's class. And then I'll go, actually, you don't have a programming assignment due this week. So that's what we'll do. Go over this week's material, and then we'll kind of open it up for, we'll give an example of this week's material, and then I'll open it up for any kind of questions and answer or questions you may have I can help you answer. Okay. So pretty much the entire material from this week was focused solely on talking about inheritance, extending other classes, polymorphism, interfaces, and these kind of things. So what exactly is inheritance, right? So Java is built on classes, right? You've seen that in the course up to this point. If you've had other Java classes in the past, you can see that Java is classes, right? Even in this example I have on the screen right now, we have a class example, right? And the class has our main method in it, but it's still a class, right? So what is a class in Java? A class in Java is kind of a combination of variables that belong to that class. We call them member variables, and methods that are part of that class. Right? And so that's what a class is. So actually, let's make a simple class. Let's make a class called car. Car.java. Let's make a class car. Okay. So what kind of variables should a car have? And by variables, I mean what are attributes of a car that make sense? Well, let's think, we can have how much mileage it has, right? Mileage. How many miles are on the car? Oh, I think there's an E in there. How many miles are on the car, right? Maybe we want to keep track of private number of doors. Is it a 4-door car? Is it a 2-door car, right? These are things, these are attributes about the car, right? Let's think of one more. What's one more? Let's just say a string for the color. There's probably more stuff. That's actually a lot more stuff to a car. There's how big the engine is, a million different things about a car. But for our example, we're just going to keep track of these 3 things. The mileage on the car, the number of doors on the car, and what's the color of the car. Okay. So let's think about what the methods are. Well, we always need a constructor. And as you note here, your variables should always be private. And when it's marked private, it means it cannot be directly accessed outside of this class. But your member variables, they can be a combination of public and private. Public means it can be accessed outside the class, but it just depends on what you want to do with the method. But every class really needs a constructor, right? And this is what a constructor looks like. It has the same name as the class. It doesn't have a return type, and we'll see return types in other methods that we make. But it has the same name, and we can have parameters or we cannot have parameters. So if there are no parameters to this car, let me take one step back. The purpose of a constructor is to set the initial values for your variables, right? So this is what we call a default constructor, and default means we don't give it any parameters. So we want to set the internal variables to some default values. So let's say we have mileage will be 0. It'll start out at 0 miles. The number of doors, the default is 4. It could be 2. I'm just picking 4. And we'll say the default color is black. All right. So that's a default constructor. We can have other constructors. Again, a constructor is just public, the name of the class, and then we can give it values. We can give it parameters in this case. Let's say we want to give it the mileage. So how could we set up the initial values? Well, the mileage the class is mileage. That's why I use this. This means the class itself. So this mileage is equal to the mileage passed in. We still need to set up the other values, the number of doors and the color, but since they weren't given to us as a parameter, we can still set them to the default. Number of doors equals 4. This dot color equals black. Okay. We could have another constructor of a car that has the mileage, the number of doors, and the color. String color. So then we know what to set them all to. We can have this, the mileage is equal to the input mileage. This dot number of doors is the doors passed in. And this dot color is equal to the color passed in as a parameter. We can have all these as constructors, but the point of a constructor is just to set the initial value for all of the variables. Okay, so we have this car that has these 3 constructors. Right. So methods besides the constructor are things that you can do with a car. Think of them as, say, actions, verbs, things you can do with a car. Well, what's something we can do with a car? So, and if we want to access outside the class, we have to label it public. We put the return type. If I put void, it means I don't have a return type. I'm not returning anything. Let's say, what can we do with the car? We can start it, right? Start the car. So that's a method. Actually, let's have one more variable up here. Private, it'll be a Boolean. You know, is it running or not? So by default, it is not running. Okay. So if we want to start a car, this is our chance to modify the internal variables to represent that state of a car. So if we start a car, the running becomes true, right? That makes sense. If we start a car, it's now running. Running is true. Conversely with that, we could turn it off. We call it stop or shut off. Let's just call it shut off. We make the running back to false. All right. Let's make one more method that returns a string called toString so that we can print out what the internal state of the car is so we can see what's going on. So let's just make it, let's say, what do we have? We have mileage. So we'll print out this dot mileage plus, actually, let's make it pretty. Miles, you know, this dot mileage plus, we print out, what we got else we got doors plus this dot number of doors plus, what's we got the color, have it show us the color, and then we got running, whether it's running or not, right? Running, we'll put that into a string and then we'll return that string. Okay, so that's what we got so far. We have a car is these parameters. This describes the car, saying how much mileage, the number of doors it has, the color it is, and whether it's running or not. These are our constructors setting up the default values or the starting values for those internal variables. And then we're going to have just 2 parameters. One is to start the car, one is to shut off the car. What that does, it modifies the internal running variable to either true for running or false for running. And then we have a toString that just takes all the parameters, turns it into a string, and then returns that string. So let's save that car. Now let's go to our main method here. So let's make a car. So we have a car is equal, C is equal to, it's a new car. Make it like that. So this is constructing a new car with the constructor, right? So if we don't have any parameters to it, then it uses this constructor, and these will be the default values, right? So let's print out what the car is. So as you remember, we made this method of the car called toString. And what toString does is it returns a string with all of this information in it. And so we're just going to print that out. Let's save it and let's run it. So I have Java. So let's get the rest of this off the screen. Java C example.java and car.java. Right. Oh, I have an error. Oh, I fat fingered something. Oh yeah, this is not Python. This is system.out.println. Right. And then car.java line 16. Yep, I misspelled this. There we go. Fix my errors, compile it. Compile is fine this time. Let's run it. Example. So let me show it. So we made a car with the default constructor, and then we printed it out. And indeed, this is the default values for our car. Additionally, we can use other constructors. What else we got? We got one where we can say what the mileage is. Let's say the starting mileage is 1234. Save it, and let's compile, run. There you go. So now the miles is what we gave it as part of the parameter to the constructor. The doors, the color, and the running are all still the default values. Okay. What else do we got? Other constructors. We got one where we can say the mileage, the doors, and the color. So let's do that one. So that's the mileage. Let's make it a two-door, and the color is red. Oops. Let's save it, compile it, run it. And there you go. So now I have a car with that many miles, two doors, and it's red, but it's still not running yet. But the running is false. So let's turn the car on. How do we do that? Our car is C dot our method. We want to start the car. Okay. So after we start the car, so let's print this out twice so we see what changes. And then we'll call C dot, what I call it, shut off. Yeah, that's what we called it. Then we'll print again. So what we're doing here, we're going to make the car. We're going to print out the car. We're going to start the car and print the car. And then we're going to stop the car and print the car. So let's see what gets printed out here. Compile it, run it. So there we go. Here is the car after we construct it. Notice the running is false. Here's car after we start it, running turned to true. And then here's car after we shut it off, the running turned back to false. So that's the basic usage of a Java class. That really should be a review of kind of classes of Java. That's what a class is. Okay. So how does that relate to, this week's material for inheritance, right? So what inheritance means is you have a class. You can think of it as a child of another class or a more specific version of another class. So what do I mean by that? Well, with car, there are different types of cars, right? For example, is this car an electric car? Is it a gas car? Does it run on, is it what other kind of car is there? Is it, let's just keep those two simple, okay? Is it a gas car or is it an electric car, right? And they behave differently, right? So let's think about having a gas car, just gas car. So let's make a new class as a gas car, Java. So let's make, we'll have class gas car, right? What variables do we need to have? Well, it's almost the same as a car, right? So let's copy all these. Oops. Copy those, throw them in here. So right now it is actually we got to make the constructor's name match, right? It's gas car. So it's all these things. It's the exact same as the car, except for this one has gas. So let's have another variable that is what? Gallons per, or not gallons per hour, but miles per gallon. This is, how many miles per gallon the car can get, right? So with our default, let's just say this dot miles per gallon is 25. Okay. And let's come down here. Oops. So we need that in all of our constructors. We have to initialize all the values. And then as part of the toString, we'll also add in miles per gallon, right? In MPG, this plus this dot miles per gallon. All right, there we go. So that's what we had to change to make it a gas car. What we added in this private miles per gallon. We initialized that in all the constructors. And then as part of our string, we just added it as part of our string so we can see the miles per gallon. So really that is the only difference between a car and a gas car in our example, right? So instead of car, let's call it a gas car. A gas car. It can still have that many miles, doors, and color. And the rest of it can be the same. Okay. So let's compile that and run that. Yeah, there we go. So we have miles, doors, color, running, and the miles per gallon. Because now it's a gas car. It's not just a car, it's a gas car. So, that's when you construct it, there it is when you start it, and there it is when you shut it off. Okay. So what is a little bit of the problem with this? So we have this car class with all this code in it. And as we discussed, the gas car had very little difference. We added this to the string. We added this to all the constructors to initialize the miles per gallon. And then we had this one additional variable. But we had to copy and paste everything else, right? The rest of it is the exact same. That's really a waste of effort. It's duplicating code, and duplicating code is a key sign that you should be using inheritance. So what if instead of duplicating all that code, we do use inheritance, meaning gas car extends car. And what does that mean? That means gas car, it is a car. It's just a more specific version of a car. Okay. That means gas car has everything a car has. It just adds a little bit more onto it. And then what you can do, you no longer need to duplicate the code. As you see, I just deleted these 4 variables. In gas car, I can delete mileage, number of doors, color, and running. And I can delete those because a car has those already. And since car has those, since gas car extends a car, that means gas car also has those variables. And the only thing new we're adding is this miles per gallon. Likewise here, we can get rid of this duplicate stuff. There is something you have to do, and I'll show it to you in a second, but we can get rid of the duplicate stuff because in the default constructor for car, we already set up those variables. So in the gas car, the only one we need to set up is the miles per gallon. There's one caveat to that, is that we have to explicitly tell it to use, they call it a base class, the base classes or the superclasses constructor. The superclass or the base class is what you're extending. So since we extend car, we use the keyword super. That means refer directly to the superclass. We want to do their default constructor. Okay. in this specific one, we want to do the supers constructor that takes the mileage, right? In this one, we want to do the super constructor that takes the mileage, the doors, and the color. So this means when you call the constructor for the gas car, also call the constructor for this super class. Okay. So look how much, excuse me. And then also we come down here, we no longer need the start and shut off functions at all. We don't even need them. And the reason is car already knows how to start and shut it off. And since these methods exist in this super class, that means they exist in this inherited class. So we can delete those, but they're still there because the base class or the super class had them. And then in toString, we could just delete this out of here. If we X that out and save it, and if we run it, you know, we're still calling this toString method of a gas car, and we're still calling this start, we're still calling this shut off of a gas car, but it'll use the ones here in the base class because they don't exist here. If they don't exist in the inherited class, then it'll use the ones from the super class. So let's run that. As you can see, we still get all this information for, you know, each time we start and shut it off. But what's missing here? What's missing here is the miles per gallon now, right? This doesn't have miles per gallon anymore. And why is that? Because gas car does not have that toString method. Car does, but car doesn't include the miles per gallon, right? But we can't do this miles per gallon plus this dot miles per gallon. This is going to give us an error, right? Why is that? Compile it. See, it gives us an error. And that's because car does not have MPG, right? It is not one of its variables. It belongs to one of its inherited classes, but the super class cannot use something of the inherited class. The inherited class can use the super class though. So how could we remedy this? Since car doesn't know what miles per gallon is, but gas car does. So what we can do here, we can use the same function name, and it has to be the same exact thing, toString. In here, we can put in what we want it to return. Let's just return blah, just so we can see it works. Let's run, compile it. Compile it first. Compiled, run it. And you see it prints blah, blah, blah. And the reason being is because we have a gas car, we're calling the gas car dot toString. It looks in gas car, toString exists, so this is what's going to return. But of course, we want to return all the stuff. You know, we want all of this, but plus miles per gallon. Then we want to have all that plus new line MPG plus this dot MPG or miles per gallon, right? Save it. Let's run that. Oops, what did I do wrong? Oh, yeah. Oh, one thing I didn't mention. This is actually important. So, you know, I said when these are marked private, that means they cannot be accessed outside of this class, right? And that's true. Since mileage is private, even in an inherited class, you still can't use it. Private means you can only use it within this specific class. There's another one called protected. That's what we want to use here. Protected means it can be used in an inherited class, but not outside of that. So for example, our example class, we can't use the mileage. We can't use the color because this is outside of the class and it doesn't extend car. But since gas car extends car and these are protected, it means it can be used in your inherited classes. That's what this error was. So let's compile it again. See it compiled fine. Let's run it. As you can see, now we get the whole thing. We get miles, doors, color, running, and miles per gallon. There's still a little bit of a problem with this. And the problem is, if we look at car, look at our toString, we have all this code for toString. What is the difference between it and the car? They're almost identical, right? Look at it, almost identical. The only difference is gas car just added on this miles per gallon. Again, duplication of code is generally a bad thing. So what we can do, what does car print out in this? So let's get, what would car normally make for a string? The way we can do that is just like we did with these constructors, we use super to refer to the super class. Well, we can do super.toString. We'll start off with S being that. So whatever the super toString produces is what we're going to put in this S. So it'll run this code right here and return the string. So we're going to get that string from the super class. And then let's just add on to it my miles per gallon. And then return that. Let's see if that gives us the same answer. Compile it, run it. And sure enough, there we go. We get what we wanted. Miles, doors, color, running, and miles per gallon. For example, let's take out these other ones so we don't have to look through so much stuff. We'll just make the car and there we go. There we go. We get everything. Okay. So why is this useful? You know, why didn't we just start off by putting miles per gallon in the car class? Well, because there's more than one kind of car. We could also have an electric car, right? So let's make a class electric car. It will also extend car, but instead of adding miles per gallon, let's add miles per charge. Again, and let's say this one only has public electric car, a default constructor. So we'll call the supers default constructor. And then we'll have this dot miles per charge. By default, it's 250 or something, right? And then just like we had to do for gas car to get it part of the printout, kind of want to do the same thing for the electric car, meaning copy the whole method. So to get the string for the electric car, we'll have whatever the super wants to make a string, but then we'll add, what is it, MPC, miles per charge. And then we'll print out miles per charge and then return S. So let's modify the example. So we'll make a gas car that looks like that. Then we'll make an electric car. Let's call it E. Remember, it only has a default constructor, so you can't give it any parameters. Now, of course, I could go in there and give it more constructors. That would be fine. For continued brevity, this is the only constructor it has. So we can only call it a default constructor, but then we'll print it out as well. And what we'll see here is, so we have our gas car here, has miles, doors, color, running, miles per gallon. Then we have our electric car, which is miles, doors, color, running, and miles per charge, which is 250. Okay. So that's good. So that is how you use inheritance. Inheritance means the class is a car. An electric car is a car. meaning it inherits everything that the car has. So an electric car, again, electric car has mileage, number of doors, color, and running. Even though we don't specify them here, it still has them because it's part of this super class. But then we're adding more functionality to it. We're saying an electric car also has miles per charge. This is how we construct an electric car. This is how we do the two-string of an electric car. Same thing with the gas car. The gas car is a car. It has all the same stuff, but now we're adding on this additional functionality, which is miles per gallon. And if we wanted to, we could add extra methods here. Say for miles per gallon, say for a gas car, we want to add a method, public void fill tank. And then let's just system.out.println filling up the tank. All right. Let's save that. And for an electric car, we don't really fill up the tank. What we do, we public void, we charge the car, right? And then here we'll print out system.out.println charging the car, right? So when I go to example, we can print it out, and then we'll take the gas car and we'll fill tank. For the electric car, we'll charge it. Let's see what happens. So there we go. We have the gas car, miles, doors, color, running, miles per gallon, and we're filling up the tank. For the electric, the miles, doors, color, running, miles per charge, and charging the car. And that's because even though car doesn't have fill the tank, car doesn't have charge, they are part of these inherited classes. So this is how I'm taking this super class known as car, and I'm giving it additional functionality. And the additional functionality for an electric car is to charge it. The additional functionality for a gas car is to fill up the tank of gas. Okay. So that is the basic breakdown of how the inheritance works. So what kind of example do I want to do? Actually, I've done most of the example, throughout talking to this. I was going to do an example on cars and gas cars and electric cars. And that's kind of what I've done here. One thing you can't do, well, lots of things you can't do in Java. But in some other programming languages, speaking specifically like C++, you can have multiple inheritance, meaning that I can extend, in C++, I could say extend car and I don't know, what's something else that makes sense? Gas car. Let's say transportation device or something, right? Because a car, a car is a transportation device, right? A gas car can be a transportation device. So in something like C++, we can do this where we extend two classes. C++, we can do that. In Java, you can't do that, right? You just can't extend two classes. It's not permitted in Java. It's not that it's discouraged, it's you just can't do it. This will give us an error. Even if we make a class called, transportation device.java, even if we make the class transportation device, let's give it some variable, print int distance or something. I don't know how far it can make you go, right? Make a constructor of transportation device. It'll take that distance. We'll save it. This stuff distance. Let's make a variable called, or a method called go. And what it'll do, it'll system.out.println print going, whatever this distance is. This is a silly example, but it's going to make a point, distance. Okay. So we have this class called transportation device. So let's say we have a gas car. We want to extend car and transportation device. You just can't do that in Java. It is not allowed. You know, if we try to compile this, it gives us an error. You can't do it. What you can do in Java, though, is what we call an interface. An interface is very similar to a superclass. The difference is, though, it doesn't actually do any implementation. And you'll see what I mean by that in a second. When we talk about a superclass, for example, car is a superclass in our example, right? Car is the superclass. So car has variables. Car, it has methods, and it actually does the code for the method. Meaning in car, we have a method called start, and then we do the work for start, right? In an interface, instead of saying class, we say interface. But an interface cannot have any variables. So I deleted that variable. An interface cannot have a constructor. An interface can say what the method is, but it can't do any code for it. So, you know, for this go method, you know, I had this a minute ago. So I have a method called go, and I actually do the work for the method. You know, I print something out. With an interface, you can't do the work. You're only saying what the method is. And how is this useful for us? Well, that means here, we still can't extend the car and a transportation device, but we can, what we call implements it. We can implement this interface. We're still extending the car. That means whatever is in car, we have in gas car, but we're also implementing this interface. That means whatever methods are in this interface, we have to have those same methods in gas car. So actually, if we try to run this compiler right now, it's going to fail. The reason why it fails is we're saying this interface has a method called go. And in gas car, we're going to say we implement this interface. That means we have to actually make that method in here. I haven't made the go method yet. So Java is going to give me an error when I try to compile it. And there you go. It says the class gas car implements this transportation interface. And it's going to say gas car is not abstract, and it doesn't override the go method in transportation device. So we need to make that go method, public void go. And for a gas car, we'll just say system.out.println. We'll say going in a gas car, you know, something like that, something silly like that. So if we compile that, now it compiles fine. And so in our example, we can have, and we said it's gas car, right? Yep. We'll fill the tank. We'll have a gas car. Go. Let's run that. Compile it. Run it. And it works fine. We're saying there's miles, doors, color, running miles per hour, filling up the tank, and going in a gas car. Can we do the same thing with an electric car? You think we can do that? The answer is no. The reason why, the reason being, there is no go method in an electric car. It didn't give us a compile error. It gave us a, well, actually it is a compile error, but saying go is not a method in electric car. That's because in electric car, we also need to implement a transportation device. We also need to void go, make the go method, and then actually make the code for what happens when you go in an electric car. Going in an electric car. Save it and run that. Compile, run. There we go. So there's our gas car, miles, doors, color, running, miles per gallon, filling up the tank and going in the car. Then we have our electric car, which has miles, doors, color, running, miles per charge, charging the car, and going in an electric car. So that's how you can do kind of pseudo-ish multiple inheritance, but it's not multiple inheritance. It is inheritance as far as the car, but then you're saying implement this interface. And you can implement an unlimited number of interfaces. That's fine. So we have transportation device. We can have something, some other interface. You know, as long as all these actually exist, you know, you can do as many implementing of interfaces as you want. All right, so let's take this back off here. So that's the example. And that covers really all of the material for this week's class. I did get one email question, I think earlier today or yesterday. Let me make sure I cover over it. Well, actually, no, rewind. There's one more thing I want to show you as far as inheritance goes. Okay, so far I've been showing you a base class, a super class that we made ourselves. We made this car ourselves, right? We made car, electric car, extends car, gas car, extends car, so on and so forth. But in Java, there are a lot of built-in classes. You can also inherit from built-in Java classes. The way we're going to show that is there's a Java class called rectangle. I think it's first we need to import it. Import Java. I think it's awt.rectangle. All right. So we're done with cars for now. So we can make a rectangle. Rectangle R equals the new rectangle. And then let's just print it out. System.out println r.toString, right? So there's a built-in Java class called rectangle. We're going to make a new rectangle and then print it out. Okay, compiled, success, run it. There you go. This is what the Java rectangle prints out. And this, like I said, a built-in Java class. This is what its printout looks like. Okay. So just like we extended the car, we can extend built-in Java classes. All right. Actually, let's look at rectangle for a second. Rectangle provides us a lot of functionality, and here it is. This is the the documentation for the built-in Java rectangle class. It's telling you it's a class rectangle. It's in Java AWT namespace. It's telling you these are all of the variables it has: height, width, and X and Y position. These are all the constructors a rectangle has. These are all the methods a rectangle has. Note has add, contains, create intersection, get bounds, get size, get height, so on and so forth. You can read through all these. These are all of the methods that a built-in rectangle has. So if we want, we can extend this rectangle class, meaning we have access to everything it already provides, but we want to add more functionality to it. So what else can we do with a rectangle? Let's say, what if we want to be able to get the area of a rectangle, right? Do we see anything in here? There's nothing in here that lets us compute the area of the rectangle. So let's extend the rectangle to give it additional functionality to where we can get the area. Okay, there's my code. So I have this class. I called the class myRectangle. We are going to extend this Java AWT rectangle. Okay. So let's just leave it at that, and let's make a myRectangle and see what happens. So example, instead of rectangle, we're going to make a myRectangle. We don't need to import this anymore. So I have a myRectangle, and then we'll still print it out. Let's compile that. Java C, run it, and there we go. We get myRectangle, and then we still get this same kind of printout. And that's because the Java AWT rectangle in its toString, it just prints out all this information. It prints out the class and then, the X, Y, width, and height. So our class has inherited, my class has inherited that toString method. And of course, if we make our own string to string, and we can string s equals here, or whatever, return s. So now, So now when we do this, all we get is the here, because we're not taking advantage of the super classes functionality. All right, so actually, let's add in some more functionality. All right, so what can we add in for the rectangle? Like I said, maybe we want to compute the area. So let's have a public int. We'll compute area. And how do we get the area of a rectangle? Well, it's the width times this dot height. Oops. We'll return the width times the height because that's the area, right? I mean, I don't have variables up here called width and height, but since I extend this Java AWT rectangle, I have access to everything in rectangle. And in our documentation, it tells us that it has a variable called height, has a variable called width, so we should be able to access it. And so then let's take advantage of that. So in our toString method, let's use whatever the super gives us. And then let's add on, just like we did with the electric car and we added the miles per charge. Here we want to add on, let's just put some spaces in there, and then we'll say area equals whatever the area is. And so what's the area? Well, we have a method to get that. We'll compute the area. Let's save it and run it. Compile, run, and there we go. We have the super class gives us this much, and then with our method, we tack on there what the area is, and the area is 0. Why is that 0? It actually makes sense because the width and the height of this rectangle is 0. So let's actually fix that. Let's look back at the constructors for this. So we have a constructor. One of the constructors is a rectangle with a width and a height. So let's call the super constructor with width and height. So let's go back to our code. So let's make a constructor for my rectangle, give it the width and the height. And then just like in the car where we called the super constructor, we can call the super constructor here. This is going to call the Java AWT rectangle constructor with the width and the height. We'll save that. Let's go back to our example, and in the constructor, we'll give it a width of 10, a height of 4. Let's run that, compile, run, and there we go. Now we can see the width and the height, and then we can see the area computed correctly. So this is an example of how you can use, how you can inherit, how you can extend built-in Java classes instead of just classes we make ourselves. And it's important to remember that my rectangle, it is a Java AWT rectangle. It's just, this rectangle is this rectangle with more functionality. And this is the more functionality we're giving it. Okay, now that's this week's material. Let me look up the question that I received real fast to make sure I covered it. All right, wanted me to talk about array list. Okay, so we have this car, electric car, gas car, right? So we'll kind of use those in an example. So we have this concept of an array list. This is a built-in Java class, and it allows us to maintain a list of items. Okay. but we have to specify what kind of list we want it to maintain. That's where these braces come in. It's greater than or less than. Inside of here, you put the type that you want to maintain a list of. For us, let's just maintain a list of floats. And we'll just call it list, and we'll make it a new array list. Okay? So what this is doing, we're saying we want a list. The type is going to be floating point numbers. That's the variable name for it, and this is me creating the list. So I need the type here, but for brevity, Java lets you omit it here because it knows this is what you want because you already typed that once. And so with this list, it has various methods you can use. Actually, let's look it up real fast. Let's look up Java array list. Let's get the documentation. And here we go. This documentation, these are the constructors we're using. We're using the default constructor. And as you can see, we use the default constructor, no parameters. Okay. These are the methods we can use. We can add something to it. And in this example, E just represents the type that you're storing. And here we said we're storing floats. So we can add a float. We can add a float at a specific location. We can add all. We can clear, clone, contain, so on and so forth. You can read through all of these methods that it gives you if you want. We'll cover a couple of them. So one of the things we can do with the list, actually, let's first print it out. System.out.println. Let's just print out the list. Let's just print it out without doing anything else to see what it says. Compile. Oops, new array list. What did I do wrong? Oh, cannot find socket because we got to import it. Luckily, it has it up here. It tells us it's in java.util. So we need to import java.util.ArrayList. So that's what we're using. Now we should be able to compile it. There we go. Run it. There you go. It prints out these empty brackets right here. That's because the list is empty right now. Well, let's add something to it. Let's take that's some in here. Let's do list.add. Let's give it a floating point number to add. All right. And then we'll print it out. Oop, we got to compile it first. Run. Now you see it prints us out that float that's part of the list. Let's add another number. Let's add a few numbers. 2.2, 3.3. We'll add all those numbers to the list. And there we go. It has all those numbers in that list. So this one variable called list, it represents all of those numbers. Okay. So, what good does this do us? Well, it means we can do repetitive operations on each of the items in the list. Well, first of all, how do we access an individual item? So this list gives us everything in there. There's a method called get. Let's look it up. Get returns the element at the specified position in the list. We can do .get, and in the parameter we need to give it is the index of the one we want to access. So Java index to start at 0. So the 0 thing in the list is this. This is the 1 thing in the list, the 2 thing in the list, and the 3 thing in the list. So let's get the index 2 item. We'll print out the list.get2. So this is 0, this is 1, this is 2. So this should print us out 2.2. And indeed it does. It's just 2.2. It's not the whole list anymore. It's just that one specific item. So what's some things we can do with this? We can do a loop over it. We can say for in I equals 0, I less than the list. Another method, list.size. List.size tells you how many items are in the list. That's a basic for loop. Should be familiar with them. So let's say it's going to be list.get the one at the I index and then add 1 to it, and then we'll print that out. Just doing some simple math. And we'll print out this val, right? So what's happening here? We're making a for loop. We'll have this I variable. It starts at 0. It goes up through list.size. And then each time we increment it by 1. So we're going to say the list at the I index, we're going to add 1 to that value, and then we're going to print it out. So if we run this, run it, as you can see, it's printing out 1, or each of those numbers plus 1, right? So we went through the whole list and then did something with that item in the list and did some kind of operation on it. So there's more than just add. Let's go back to just printing out the whole list so we can see changes in the list. Print ln, just print out the whole list. So we added those things. Let me put a delimiter in here so we can see where one list ends and the other begins. Actually, we don't need to do that for the list. All right, so we added those things. Let's remove something. So how do we added these things to the list. How do we take something out? Well, let's see what we got. We got this remove. We can remove something at an index, or we can remove something by the value of it. We can remove at O. So what we can do list dot remove. Let's say if we remove index 1. And let's print it out. So here we will add all these things to the list, and then we'll print out the list. Then I'm going to remove this from the list and then print out the list. We're going to remove index 1. And if this is 0, this is 1. So the second list should be missing 1.1. There we go. And there we go. We have the whole original list. We removed the index 1. And so the index 1 was removed. Likewise, 2.2, I think this should work. Make sure I'm not messing up. Yep, there we go. So likewise, instead of saying an index, we said remove this very specific float. Remove float 2.2. As you see, we had this list, and then after we removed it, we removed the 2.2. So that's array list in a nutshell. Those are the most important things for an array list. The most important things are, in here you put in the type that you want it to store. Here's how you add things to it. Here's how you remove things through it. And I just showed you how to go through the whole list and do operations one at a time on the items. These don't have to be just normal items. These can be our cars. Let's do this. Well, now we can't add floats because we're adding a car. Let's add a new car. Let's add a new car with mileage. Let's add a new car with, we have mileage. What was the other constructor? Mileage, doors, and color. We had mileage. It has 3 doors for some reason, and the color is yellow. It's a very odd car. Okay. Then let's print that out. Let's see what that looks like. Save it. Run it. So now we have a list of cars. Right? Miles, doors, color, running, false. That's the first car. It's up to that comma. Here's the second car, miles, doors, color, running, and here's the third car. Okay. So we can have a list of cars. Imagine if we're at a car dealership or something. We can have a list of the cars, and then we can add each car that we own to that list. Okay. Well, let's look at it. What else we can do with if we iterate through them, if we have a loop for them. For int I, start at 0. go list.size, meaning if there are 3 items in the list, there are 3 items in the list, and this size is equal to 3 plus I. This lets us do just a simple for loop over all the items in the car. Car C is equal to the list dot get the I car. That means this car that we're calling C, it is the one at index I. So the first time through the loop, you know, I is equal to 0. So this is list dot get 0. So car is this 0 car. Let's start it. C dot start. And then we can do system dot out dot println. We can print that car. So this is how we're doing an operation on all, dang it, all the cars in the list. We added some cars to the list, and now we are going to go through with a for loop. We're going to get each of those cars, and then we're going to start each of the cars, and then we're going to print out each of the cars. Save it. Go compile. Go run. And as you see, that's the first car. If we look at our constructors, it makes sense. Move this over here so we can see it. So the first car was just a new car with the default constructor. As you note, those are the default values. Then we get the second car. We said its miles are 1, 2, 3, 4, 5. You can see there is the second car, miles, doors, color, running. And then we get the third car. We start it. Hold on a second. Car to start. Oh yeah, we just made running true. That's sorry, that's the difference. Where's that? Yep, there we go. And you know, there's the third car with miles, doors, color, and running. So that's what our array list is useful for. It's useful when you don't know how many cars you have. You know, we could have done this. We could have made an array of cars, right? Cars. That would let us store 3 cars, you know, and then we could have done car 0 is equal to new car, you know, so on and so forth. You know, we could have done that, right? To have an array of cars. But now what happens if we have 4 cars? Well, we have to go back and find this and add 4, right? What if we have 400 cars? We have to go back and we have to add 400, right? An array list lets you skip all that because it'll let you add basically unlimited number of cars to this list. And you no longer have to keep track of where the index is, how many cars are already in there, and how to remove cars. This keeps track of all that for you. So that's an array list. One more thing, not array list related anymore, but another question was, what is the difference between static and not static as you're talking about classes? Okay, so let's go back. Look at our car class. Okay. So none of these are marked as static. If it is not static, it means it belongs to that specific instance. And what do I mean by that, by instance? If we look here where we're making cars, let's get the array list out of here for a minute. So let's make a car. Car 0 is this new car. Then we'll have car 1 is this new car with this many miles on it. Okay. That means car 0 is a different instance from car 1. They are not the same car. They're both a car, but they are their own individual car, meaning all the variables belonging to a car, they are unique from each other. Meaning even though this car 1 has this many miles, this car 0 has its own completely independent miles. Okay, that is non-static, meaning it belongs to a specific instance. Now oppose that if we have something static. Let's just make it public for easy access. Actually, no, we'll still make it private. Let's say we have the keyword static, and I'll show you what it means. Say it's an integer, it will be number of cars made, right? Then let's have a variable, excuse me, a method, also marked static, turns an int, and it's called get number of cars made. And here it'll return car dot number of cars made. So what the static means here is that this variable is no longer unique to each instance. That means every variable of type car shares this number of cars made. That means even though I have car 0 and car 1, they each use this exact same number of cars made. And we declare that when we say static. And so when there's a static variable or a static method, so we have this one called get number of cars made, you cannot do this. Car 0 dot get, actually let's print it out, system out print ln. See, car 0 dot get number of cars made. You can't do this. Compiler should complain. I hope it does. Oh, it doesn't complain. That's unfortunate. Yeah. I guess newer versions of Java let you do that. This is bad practice, I'll tell you that. And the reason being is that since this is static, you need to refer to it as the class, meaning class, the name of the class dot get number of cars made. There we go. That, and so it's 0. But as I said, it still holds true that this number of cars made is the same for every instance of it. So for example, this get number of cars made, maybe it can keep track of how many cars we've constructed so far, right? So maybe here for car, we increase the number of cars made. So each time we construct a car, each time we call a constructor, we're going to increase the number of cars made. So this theoretically should keep track of how many times we make a car, right? Let's save it. So here, let's put it in different locations. So what should happen here? So we're first, before we make any cars, we're gonna get how many cars made. We're gonna make one car and then print it out, and then we're gonna make a second car and print it out. And a reminder, each time we construct a car, we're increasing the number in this variable by 1. So each time a constructor gets called, that number should go up by 1. And since it's static, it means it's shared over all instances of this class. That means the car 0 get number of cars made is the exact same as the car 1 get number of cars made. Save it and run it. You see we get 0, 1, and 2 because at first this is 0. When we call a constructor, it's now 1. When we call another constructor, it's now 2. You know, we can print this forever. We can do for int I equals 1,000. Excuse me, I is equal to 0. Let's do a simple loop that does 10,000 car C equals new car. You know, we can store it in a list if we wanted to. I'm not going to do that. I'm just going to construct them, not really do anything with them. And then we'll print it out. So what should be printed out at the end of this? It should be like 1,002, because here I've made 2 cars. Here I'm making, well, actually 10,000 more cars. And it keeps track of that for us. Run it. And there you go. Get number of cars is 10,002. Now, suppose that, you know, if this was not static, you know, we have to turn it back into this. Save that. And in our example, we can no longer use the car because it's not static. Let's see if we can try to compile it. It's all kinds of errors because it's not static. We have to use specific instances. So for here, we use car 0. Here, let's just use still car 0. And here, let's use car 0. What's going to be the printout here? It should be all ones, I believe. Compile it, run it. You see, it's all ones. And that's because I made it is no longer static. It means it is unique to this individual instance. And so for this car 0, I've only made one car 0. So that's the difference between static and non-static as it opposes to classes. So that should cover the question that I received. All right. So we've got about 20 minutes left of our time. I'll go ahead and open it up to questions. If you don't have any questions, that's fine. And again, this video is being recorded. Yes, I did the recording. So I will get it put up on YouTube and get sent out tonight. So I'll go ahead and open up for questions. All right, nothing heard so far. I'll wait about 1 more minute if you come up with anything. If not, I'll go ahead and shut it down and get the video uploaded. All right, looks like I'm gonna go ahead and shut it down. Everybody have a good night.